Hi everybody, this is Mrs. GA, and today we're going to do a little bit of algebra review. So the reason why we're going to do this is because these are some really important skills that we're going to be practicing throughout the year, just so you don't forget them as you move on to Algebra 2 and beyond. So the main skills we're going to be practicing are solving linear equations, solving systems of linear equations, and solving quadratic equations. So those are three really important skills that we have to maintain. So first we're going to start with solving linear equations. Hopefully some of the stuff is a total review for you and it seems pretty straightforward. So here we're solving for x. So remember our goal is to isolate x on one side of our equation. So here's our variable, which means that we need to get rid of these other two numbers. So we have the 10 and the -2, and we can move them using the inverse operations. So we always start with adding or subtracting. So the inverse of subtraction is addition. So I'm going to add 2. But remember, our most important rule from algebra is the property of equality. If I add 2 on the right side of my equation, I need to do the exact same thing on the left. So if I add vertically, I'm left with 5 equals 10x, and then the 2 is gone. So this I can read as 5 equals 10 times x. If a number is touching a variable, it represents multiplication, and the inverse of multiplication is division. So I can divide both sides by 10, and I'm left with 5 over 10 equals, well, 10 divided by 10 is 1, so I'm left with 1x, which I just write as x. Now, of course, I'm almost done solving because my variable is isolated, but we do need to simplify the fraction. So I'm going to divide the numerator and denominator by 5, which leaves me with 1/2 equals x, and that is my final answer. Okay, let's look at this next example. So here's my variable. So I can start by doing the inverse of addition, which is subtraction. I can subtract 12 from both sides of my equation. And I'm left with 2x over 3 equals -8. So you'll notice that I moved the x to the numerator. So I can leave it in the middle out to the side, or I can put it in the numerator. Either way is fine. So now I look at this and I say, I see 2 times x divided by 3. So I'm going to start by doing the inverse of division, which is multiplication, and I'm going to multiply both sides by 3. So 3 divided by 3 is 1, so it disappears. I'm left with 2 times x equals -24. And the inverse of multiplication is division. Divide both sides by 2, and I'm left with 1x equals -12. There you go. And last, here's one where I have a variable on both sides of my equation. So this is something I'm going to need to take care of first. My little trick is that I always like to pick the variable with the smaller coefficient to move. So I'm going to be moving positive 6x. So I can do that using subtraction. I could subtract 6x from both sides of my equation. Notice I line it up under my common x term. So here I'm left with 3 equals 2x plus 5. So notice that I'm only combining terms that are the same. 8x minus 6x is 2x. 5 is a separate type of term, so it stays separate. Now here's my variable, which means I need to clear both of these numbers. So I'll start with this one. The inverse of addition is subtraction. So I'm going to subtract 5 from each side. I'm left with -2 equals 2 times x. And the inverse of multiplication is division. So I'm left with -1 equals 1x. Remember, any number divided by itself is 1. So that's a brief review of solving linear equations. Definitely something we will practice throughout the entire year, and it will definitely show up in a lot of geometry problems. Okay, the next skill we're going to learn is solving systems of linear equations. There were 2 different methods that you learned in Algebra two main methods that you learn for solving. So substitution and elimination. So we'll do one of each. So the idea of a system of equations is that there are two equations and two variables. So now we're not just solving for x, we're solving for x and y. The only way to solve for two variables is if you have two equations. So this first one, we're going to use, like I said, the substitution method. I'll write it on the side here. So I will choose to use the substitution method whenever I see that one of my equations says y equals something or x equals something. So this means that wherever I see a y, I can substitute x minus 1 because they are equal. So then if I look up at my first equation, I notice that I have a y right here. So what I'm going to do is I'm going to substitute x minus 1 into my first equation. First, notice I take out the y and replace it with a blank space using parentheses, and then I replace it with x minus 1. Whenever we substitute, I'm going to ask you to do it with parentheses. So now I just have to solve. So I can solve this one, which is now a linear equation, by first distributing. I need to see if I can combine like terms, and in order to do that, I'm going to need to distribute. So I'm going to distribute the negative 3 to x and negative 1. So I have 2x. Negative 3 times x is negative 3x. And remember, that's why I like to draw on these rainbows. We also have to do negative 3 times negative 1, which is positive 3, equals negative 1. So now we can combine like terms. You'll notice that these two variables are on the same side of the equation. They're both on the left side, which means I don't need to use an inverse operation. I just combine them. So if I have two x's and I take away 3, I'm left with negative 1x plus 3 equals negative 1. Now I'll do the inverse of addition, and I will subtract 3 from both sides. So I'm left with negative x equals negative 4. And last, we need to make sure that even the negative is gone. We're not completely done solving here. So this we can read as negative 1 times x. So we can actually divide both sides by negative 1, leaving us with x equals positive 4. Now, again, we're solving a system, and like I said, we aren't just solving for x, we also need to solve for y. So then what we can do is we can substitute again. So wherever I see an x, like right here, I can replace it with a 4. So let's do our second round of substitution. So we have y equals, I'm going to take out the x, I'm going to replace it with a 4 in parentheses, and then minus 1. So you can see this equation, all I did was I replaced the x with a 4. And of course, 4 minus 1 is 3, so I got y equals 3. Now, systems of equations, we always write the answer as an ordered pair, like a coordinate. So remember, x always comes first, and then y comes second. So our answer is 4, 3. Inside parentheses, make sure you write it correctly. Okay, so this next example, we have another system, so we have two equations with two variables. We're going to solve this one now using the elimination method. Your teacher might have called it the addition method. Also, that's another common name, but the idea is the same. So the idea of the elimination method is that we want to add vertically, and in doing so, we would like to eliminate either x or y. So we know when we're adding, things will disappear if they are opposites. For example, if I have positive 10x here, I would like this to be negative 10x. Or if I have negative 7y here, I would like this to be positive 7y. So you'll notice that we don't have any opposites at the moment, so what you can do is create them. So, you could choose to eliminate x's or y's. So I'm going to eliminate the x terms. Again, since this says positive 10x, I want this to say negative 10x. I can do that by multiplying the entire equation, both sides, by negative 2. So let's see what happens when I do that. I'm going to rewrite the entire equation below. So I'm going to distribute. Negative 2 times 5x is negative 10x. Negative 2 times y is negative 2y. And 9 times negative 2 is negative 18. Now I'm going to rewrite the second equation from above right below it. Now you can see if I go to add vertically, I have negative 10x and positive 10x, which cancels out and it eliminates. I'm going to keep adding vertically. Here I have negative 2y and negative 7y, which leaves me with negative 9y. And last I have negative 36, which is negative 18 plus negative 18. Now all I need to do is divide both sides by negative 9, so I can solve for y, and I get y equals positive 4. Now again, I'm not done. I'm not just solving for y. I need to also find x, so I can actually go and substitute y equals 4 in either equation. I'm going to substitute it right here into my first equation only because it looks easier. So I have 5x plus, I'm going to take out the y and replace it with a 4 inside parentheses equals 9. Now I can subtract 4 from both sides. I'll use my inverse operation. 5x equals 5, and divide both sides by 5, and I get x equals 1. And of course, like I just mentioned, we're going to write this as an ordered pair, x, y, 1, 4. So this is definitely, a little bit more involved than just solving a single linear equation, but it's definitely something that we will use in geometry, and you will definitely need to know it for Algebra 2. So now we're going to move on to quadratic equations. So quadratic equations are equations that have x squared. And we're going to revisit two different ways to solve them, although there are other ways. These are just the two most common ones that you'll use, factoring and the quadratic formula. So the first view, we're going to use factoring. The first rule when we're solving a quadratic equation is we always want to start by setting our equation equal to 0. We want it to say equals 0. So this first one, you can see that says x squared equals 3x minus 2. We'd like this side to say 0. So we can do this using our inverse operations. We're going to subtract 3x from both sides and add 2 to both sides. Now, none of these terms combine. This is an x squared term, this is an x term, and this is what's called a constant. So we actually do leave them all separate. X squared minus 3x plus 2 equals 0. So from here, we're going to factor the left side of our equation. Now, there are a lot of different methods for factoring, but one method that you probably learned for factoring trinomials, I call it magic x. How it works is you create an x. Your constant, this number without the variable, is always going to go on top, and the coefficient of x, which in this case is negative 3, is going to go on the bottom. So we're going to be looking for two numbers that multiply to make 2 and add to make negative 3. So that would be negative 2 and negative 1. So those are numbers that are going to be inside our factors, and our factors are actually x minus 2 times x minus 1. And then, of course, we still have equals 0. So notice the numbers from our magic x appear inside our factors. This is one factor. This is another factor. From here, we're going to use what's called the zero product property, which I always abbreviate with ZPP. So if you ever hear me say ZPP, it's zero product property. And this property involves setting each factor individually equal to 0. So I'm going to take my first factor, x minus 2, and set it equal to 0. And then I'm going to take my other factor, set it equal to 0, and then I'm going to finish solving separately. So I'll use my inverse operations, and you can see that I actually get two different answers, x equals 2 and x equals 1. So that's very common with quadratic equations. It's very common to get two different answers. Sometimes you'll get a single answer, and sometimes you'll actually end up with no solution. So just be aware it's totally normal to get two answers when you have a quadratic equation. Okay, let's try this next example. You can see our first step is already done. We already have our equation set equal to 0. So now we need to factor. Now, this time we aren't able to use magic x because it's not a trinomial, but we can use another really important method, which is called the greatest common factor, or GCF. So essentially what I'm going to do is I'm going to see what do these two terms have in common. So you can see that they are both divisible by 2. So I'm looking at the coefficients first, and I notice that they both have an x. So my GCF is 2x. So the way this method works is you go in, you divide both terms by your GCF, but it's not going to disappear. We're actually dividing it out to the front. So the first thing I'm going to write is my GCF, 2x. Then we divide. 2 divided by 2 is 1. X squared divided by x is just x. It's going to drop down 1. Here, 4 divided by 2 is 2. The x's cancel out, so I'm just left with x plus 2 equals 0. From here, since I have factored my equation, I can use the zero product property, and I can set each factor, 2x is a factor, and x plus 2 is a factor. I can set them each equal to 0 separately. So here I will divide both sides by 2. Here I will subtract 2 from each side. And I am left with x equals 0, which is one of my answers, and x equals -2, which is my other answer. So notice that whenever we factor, we are going to be using the zero product property. That's why we factor. But remember, there are different methods for factoring, which brings me to example 8. So here we have a trinomial. It's already set equal to 0, but this one we can't use magic x exactly because of this a value. So what? We have to use a different method. So one method for factoring these types of equations, you might have learned it in Algebra 1. I call it the reverse box method. So again, we're using this method because this a value is no longer a 1. So the way the reverse box method works, it actually starts out looking a lot like magic x, except instead of just putting a 3 up top, I'm actually going to multiply these two numbers together, which gives us 6, and that's the number that's going to go on top. Our coefficient here still is going to go on the bottom, and then we fill this out just like a normal magic x problem. What multiplies to make 6 and adds to make 5, so we have 2 and 3. Now, these are not our factors. These are just going to help us with our reverse box. So the 2 and 3 that we had, we're going to put it right here and right here with an x. These other two terms here and here are going to come from our original equation, exactly how we see it. And now we're going to be working our way backwards to figure out what goes on the outside of this box. The box is what you would multiply to get the inner number. So again, that's why it's called reverse box, because we're working our way inside out. So I'm going to start with these two spaces. I know to make x squared, I need to have x times x. If I want to make a 2, the only way I can make it is by doing 2 times 1. So imagine I put a 2 right here. If I put a 2 right here and I slide across, I have a 3. 2 does not go into 3 evenly. So I'm going to check here. 2 goes into 2 evenly, which means my 2 belongs here, and I have a 1 here. Now I'm going to divide across the row or column. So here, 1x goes into 3x 3 times, and 2x goes into 2x 1 time. So my numbers, or my factors, come from the outside of my box. So I have 2x plus 3 and x plus 1. So those are my two factors. And since I have factored, that means that I am ready to use the zero product property. So I set each factor equal to 0 separately. So here I'm going to subtract 3 and divide by 2. So I have x equals negative 3 over 2, sorry. And then here, I'm going to subtract 1 from each side, and I have x equals negative 1. So again, I have two answers. Factoring with reverse box or a different method, if you learned it, is definitely a little trickier. So I definitely recommend getting some extra practice here if this doesn't look familiar or if it's a little bit tricky for you. Okay, the last thing we're going to talk about today is the quadratic formula. So this is going to be a really useful way to solve quadratic equations because it always works. As you noticed above, factoring is not always going to work, or different methods might work sometimes but not others, but the quadratic formula will always work. So hopefully this is something you remember from Algebra 1. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So my hope is that you've used the quadratic formula so many times that it's stuck in your brain forever, because this is something you will always need to know. So let's talk about where these a, b, and c values come from. Our a value is always going to be the coefficient of x. So in this case, you can see that, x squared. So a equals 1, this invisible 1. Your b value is always going to be the coefficient of x, so b equals 7. And your c value is always your constant, which is the number without the variable. Now, you do need to make sure that your equation says equals 0 before you list these a, b, and c values. Now, the other nice thing about the quadratic formula is that as long as you have the formula memorized, it's really easy to use. You're just substituting. So we do x equals negative, parentheses, b, which is 7, plus or minus the square root of, parentheses, 7 squared minus 4 times parentheses 1 times 12. Remember, we always substitute with parentheses, all over 2 times 1. Now we just start simplifying. So we have negative 7 plus or minus the square root of. I want to remind you that 7 squared means 7 times 7, which is 49. And then we have minus 4 times 1 times 12 is 48, all over 2. Now I'm going to simplify inside my square root right here. So we have x equals negative 7 plus or minus the square root of 1 all over 2. Now I'm going to simplify our square root. Hopefully you remember that 1 is a perfect square and the square root of 1 is just 1. So we have negative 7 plus or minus 1 over 2. Now we're going to deal with this plus or minus sign. It really just means that one time we're going to add and one time we're going to subtract. So we're actually going to do two separate equations here. X equals negative 7 plus 1 over 2, and x equals negative 7 minus 1 over 2. Now we're almost done. Here we have negative 6 over 2, which gives us negative 3. That's one of our answers. And here we have negative 8 over 2, which gives us negative 4. And we are all done. Now, this problem you could have solved by factoring using magic x, but we were just doing it with the quadratic formula for practice. However, this next problem, you won't be able to solve it by factoring, so it is really important that you know other methods. Now, of course, same as factoring, we're always going to start by making sure our equation is equal to 0. So in this case, you can see it's not, so I'm going to subtract 3 from both sides. That needs to always be your first step. And then the rest is exactly the same as what we just did. We're going to list our A, B, and don't forget the negatives, and C values. So notice B and C are both negative. Now we're going to substitute it into our equation. So x equals negative, parentheses, negative 7, plus or minus the square root of negative 7 squared minus 4 times 2 times negative 3, all over 2 times 2. And we simplify. Here, negative times negative 7 gives us positive 7. Negative 7 times negative 7 is positive 49. Here we have negative 4 times 2, which is negative 8, times negative 3, which is positive 24. Be careful when you're multiplying two negatives. All over 4. And last, we're going to add within our parentheses, and we get within our square root. And this is what we get. We get 7 plus or minus the square root of 73 all over 4. Now I'm going to look at this square root, and this is actually a square root that I can't simplify, which means I'm done, and this is my answer. So sometimes your answers are going to be kind of ugly, and they might have a square root, or they might not, so don't be concerned if you see that. And this is a really good example of why the quadratic formula is useful, because you wouldn't be able to solve this one with factoring. All right, so again, these are skills we're going to keep practicing all year. Hopefully you remember them from Algebra 1, but if not, don't worry. You can always relearn them or learn them the first time around, and practice makes perfect. All right, thank you for watching.